Today, I'm going to take a look at the sensitivity effects of surface condition on calibration blocks. You've probably got one of these. This is a 3/4 inch ASME basic calibration block. These are used for non-piping applications in ASME, which is a roundabout way of saying mostly vessel stuff. A lot of these look just like mine. There is a shiny nickel plating on it to prevent corrosion. And this one is my extended range variable thickness or ERVT block from PH Tool. This is what we use for piping applications over 20 inches in diameter. That's where ASME lets you get away with a flat block. We've talked about this part before. The rules in ASME for piping state that the calibration block has to be within 25% thickness of the pipe. That means sometimes you're hauling around a lot of calibration blocks. So what we did with PH Tool is we put 6 steps all in one block. Using just one block, you get coverage from 0.2 to 2 inches in the United States, Liberia, and Myanmar, and 5 millimeters to 50 millimeters in literally every other country in the world. Now, one thing you'll notice about the ERVT block is that it has a noticeably less shiny surface than the other block. For sensitivity blocks, when you're making a TCG, the surface finish of the block should be similar to that of the test piece. Not even should be, actually shall be. It says right in the ASME code. Now, I haven't seen all of the welds in the world. None of us have, but when you're in the field, and I mean maybe in a ditch or up on scaffold in a pipe rack, or maybe in a gas plant in the middle of nowhere, does the surface finish of your weld look more like this, nice and shiny and nickel plated, or does it look more like that? If the surface finish of your calibration block doesn't match the surface finish of your test piece, then we're not in bounds as far as the code is concerned, and we're kind of missing the point of the sensitivity cal. If you use a nice shiny calibration block to do the TCG, the reference signals in there are going to be really loud because the surface is so nice. So what happens is you end up making a TCG with a lower reference level, and that means a less sensitive inspection. Let's take a look at a practical example. First thing I'm going to do is make a TCG on my nice shiny block. We'll put one point here, and then we'll put another point down around over here. Then we'll compare that to the response on the ERVT block with the more representative surface finish, and we'll use the same 3/4 inch step and same reference reflector. With the block set on its side, the first reflection on the hole is about between 4 and 5 decibels lower, and the second reflection is actually 9 to 10 decibels. And in UT, we're used to this plus or minus 2 decibel tolerance on our sensitivity, and you can see right away we're way beyond that. And just to prove that the surface finish on this is more representative of a real weld, we can run a quick transfer correction. I'll use the 3/8 inch step on the calibration block. We'll take the probe pair, keep it away from the reference reflector, make sure you turn your machine to pitch catch, and we'll do a quick TCG. Move the probe pair back over to the test piece. You can see here, we're very close, within about 1 decibel. What I'm talking about overall here is the surface finish on your sensitivity calibration block that you would use for weld inspection. If you have things like an IOW beam profile block, or even just a simple step wedge, it's fine for those to have nice shiny surfaces on them because we're not using them to set amplitude for weld inspection. Now, the surface finish on this is dull. That doesn't mean that it's just bare steel. PH Tool does apply a very thin plating process to these to extend the life. The surface finish of your calibration block has to be representative of the test piece. That part's in the code. If you calibrate on a shiny block, that's going to result in a lower sensitivity on your inspection, which means you may be missing indications once you take it from the shiny block and put it on the real test piece. I hope you enjoyed the video. If you did, please hit the like and subscribe buttons, and thanks for watching.